Jai Jagannath. So, welcome to More Physics. This is last lecture of this chapter 25, lecture 4. So, whatever I have already derived the formula, so I have kept in this board. So, take a screenshot so that this will help to solve the numerical. So, first we have discussed the current density J. J is equal to current per area, I by A. And I is equal to dot product of current density and area vector. We know J is equal to E by rho. E is the electric field, rho is the resistivity, and 1 by rho is sigma conductivity. Say another derivation way I had done, so that is the relationship between current and drift velocity. So I is equal to NEA VD. Rho is equal to E by J. R is equal to rho into L by A. Rho is called specific resistance or resistivity, and how the temperature changes, how the resistance changes with respect to temperature, that is the relation. Alpha is called coefficient of temperature, coefficient of the resistance. Similarly, with change in temperature, resistivity also change. This is the formula, and this is the electrical circuit. So when switch is open, the terminal potential difference V is equal to E, and when switch is closed, so when switch is closed, the terminal potential difference is less than E, that is E minus I into R, E minus IR. And here internal resistance can be found by by taking the formula here, R is equal to E minus V by V into R. And the power output of this circuit is equal to E into I minus I square R, which is equal to I square R. This is the net output power. And this is the case when power is delivered by the source. Power is delivered by the source. So here, this is the, here we are charging this battery. So here V is greater than E, or V is equal to E plus IR. Then this is the power relationship between the source and the EMF. So here this is the circuit during power absorbed by the source. So when power is absorbed by the source, direction of the current inside the source is from positive to negative. When power is delivered by the source, direction of the current is from negative to positive. So now we will solve some numericals. Now let us solve example 25.1 and 25.2. You see, here an 18 gauge copper wire. 18 gauge copper wire means it is a standard copper wire. So which has a diameter of 1.02 millimeter. That means suppose this is a conductor. This is a conductor. The diameter of this conductor, diameter of the conductor is given 1.02 mm. So we are taking always SI system, convert into meter. So 1.02 into 10 power minus 3 meter. Carries a current of 1.67 ampere. So this conductor is carrying current of what? 1.67 ampere. So current is equal to 1.67 ampere. It is connected to a 200 watt lamp. So I is equal to 1.67 ampere. It is connected to a 200 watt lamp. So this is the load, 200 watt lamp. So we don't know what is the resistance of this bulb, we don't know. So now the electron density is given this. Electron density means number of electrons per unit volume is given N. So that is equal to 8.5 into 10 to the power 28. This is number of electrons per unit volume, that is small n. And the resistivity of the copper wire can be found from the table, that is 1.72 into 10 to the power minus 8 ohm meter. So what we will find? We have to find first bit. We have to find first bit current density, that is J. You know J is equal to I by area. So here I is equal to what? 1.67. Area. So this is the circular cross-sectional area. So that is pi by 4 diameter square. So that is equal to 1.67 pi by 4 diameter is 1.02 into 10 to the power minus 3 whole square. Now calculate this. So I think you will get the current density is 2.04 into 10 to the power 6. Current density unit is ampere per meter square. Okay. So here you see, then we have to find the drift velocity. Drift velocity. So you know the relation I is equal to NEA/VD. Okay. So that implied VD is equal to I by NEA. So I is 1.67 divided by N is 8.5 10 to the power 28 into E. E is the charge of electron, that is 1.6 10 to the power minus 19 coulomb into area. So what is area? It is pi by 4 d square. D is 1.02 10 to the power minus 3 whole square. So if you will calculate this, you will get the drift velocity, that is 0.15 millimeter per second. This is the drift velocity. Then C bit. So this A and B bit is for example 25.1, and the C, D and E bit is for example 25.2. So here question is electric field in the wire. How will you find the electric field in the wire? We know there is a relationship between that current density is equal to J is equal to E by rho. So that implied E is equal to rho times J. So rho is given 1.72 10 to the minus 8 into J. We have got J is equal to 2.04 10 to the power 6. All are in SI system. So if we will calculate this value, so it will be what? 0.035. And what is the unit of electric field? It is volt per meter or Newton per coulomb. Then D bit. So in the D bit we have to find potential difference between 2 points in 50 meter apart. Suppose this is the conductor of length. This is the conductor of length 50 meter. So we have to find what is the potential difference across this. You know what is the relation between electric field and potential difference? E is called negative potential gradient. If you will find the electric field intensity magnitude, it is dV by dr. So here dV is the potential difference, dr is the distance. So we can say the potential difference is equal to E into dr. So what is E? E, we have already got E is equal to 0.035 volt per meter into distance. Distance between these two terminals is 50 meter, multiply 50 meter. So if you multiply this, I think you will get 1.75 volt, meter cancel. Next, E bit. What is the resistance of 50 meter length of wire? So resistance is nothing but R is equal to rho L by A. So here rho is given, rho is 1.72 into 10 to the power minus 8 into length is given, length is 50 meter divided by area, cross sectional area of this conductor, pi by 4 into diameter square, that is 1.02 10 to the power minus 3 whole square. So if you will calculate, you will get resistance is equal to 1.05 ohm. So this is the resistance. Or you know, easy formula, R is equal to V by I according to Ohm's law. So V is equal to what? So what is the potential difference? 1.75 divided by current. What is the value of current? Current is equal to 1.67. So you calculate this, you will get again 1.05 ohm. Now test your understanding 25.1. We have already solved example 25.1. In that example, we had taken 18 gauge copper wire. But in this question, if 18 gauge copper wire is replaced by 12 gauge copper wire, whose diameter is 2 times that of 18 gauge, and same current, that is 1.67 current, if it will flow through the 12 gauge copper wire, how the drift velocity changes. Okay. So now see. In 18 gauge copper wire, let the diameter is D. But in 12 gauge copper wire, the diameter is, let us say, D dash, which is equal to 2 times of D. So here current is 1.67 ampere. Here also same current, that is 1.67 ampere. So now how the drift velocity changes? What is the formula of drift velocity? Drift velocity is equal to I by NEA. So for both the copper wire, current is constant, in number of electrons per unit volume constant, E is constant. So that implied drift velocity is inversely proportional to area. Okay, and you know area is equal to what? Pi by 4 d square. So that means the drift velocity is inversely proportional to area. Area is directly proportional to d square. So I can write the drift velocity is inversely proportional to d square. So the drift velocity in 12 gauge with respect to drift velocity in 18 gauge is equal to, the drift velocity is inversely proportional to diameter square. So this is the diameter of 12 gauge, that is d dash square. Since it is inversely proportional, so diameter velocity diameter of 12 gauge will come here, and it is the velocity of 18 gauge. So 18 gauge copper wire means here drift diameter is d square. So that is equal to d by d dash whole square. That is equal to d. What is d dash? D dash is equal to 2 times of d. So that is equal to d cancel, 1 by 2 square is equal to 1 by 4. So that means drift velocity of 12 gauge copper wire will be 1/4 times of drift velocity of 18 gauge copper wire. That means if diameter is increased by 2 times, then drift velocity will be decreased by 1/4 times. Now this is test or understanding 25.2. This question tells that maintaining constant electric field E inside a semiconductor, and if temperature is lowered, how current density changes. Suppose you see this is a semiconductor. This is a semiconductor. And in this semiconductor, we have to maintain electric field constant. That is, electric field inside the semiconductor is, let us say, constant. Now, if temperature is lowered, temperature is decreased, how the current density changes? This is the question. So you know what is the relationship between current density and electric field. So J is equal to E divided by rho. And we know for semiconductor, so this is semiconductor, it is given. For semiconductor, if temperature is lowered, the resistivity will increase, and vice versa. This is for semiconductor. But for the conductor, if temperature is decreased, rho will also decrease. So now see, here E is constant. If E is constant, so we can write J is inversely proportional to rho, since E is equal to constant. So now, if temperature is lowered, the resistivity will increase. If resistivity will increase, that is, denominator will increase, then the current density will decrease. So this is the answer. So let us solve example 25.4. This is a circuit. This is a battery having EMF 12 volt and internal resistance 2 ohm. And this voltmeter is connected across this two terminal of the battery. So this is whole is your battery. This is whole is your battery. So battery has two terminal, this end, and across this end a voltmeter is connected, and here an ammeter is connected. So what is the reading of voltmeter and ammeter? Now see, I have told resistance of voltmeter is very high and ideally it tends to infinite, and resistance of ammeter is very low, ideally it is 0. Now see, so this is the closed circuit. This is a closed circuit. So current will flow like this. Current will start from positive terminal and it will go like this, like this. Then we will find what is the value of current. So I is equal to the total EMF in the circuit is E divided by the total resistance in this loop is equal to small r plus resistance of the voltmeter. So that is equal to E is equal to 12 volt divided by small r is equal to 2 ohm. And what is the resistance of voltmeter? It is infinite. So that means 12 by infinite plus something is infinite. 12 by infinite is 0. So that means no current will flow through this path. If no current will flow through this path, then what is the voltmeter reading across the source, across the battery? So you know the terminal potential difference is nothing but E minus IR. So here E is equal to 12 volt minus, what is the current? Current is 0, resistance is 2. So that means this is the 12 volt. So this 12 volt will be measured by this voltmeter. That means this voltmeter will read 12 volt. Then what is the ammeter reading? So this is the open circuit. So this is not a closed circuit. So definitely no current will pass through the ammeter. That means the ammeter will read what current? 0 ampere. Let us solve this example 25.5 and example 25.8. So you see, this is a circuit. This is a battery source of EMF 12 volt, internal resistance 2 ohm. It is connected across a external load of resistance 4 ohm. Voltmeter is connected here, ammeter is connected here. In example 25.5, you have to find the voltmeter and ammeter reading. This is example 25.5. And in example 25.8, in the same circuit, you have to find the energy conversion rate by source, energy dissipation in the battery, and what is the battery's net output power. So this is very easy. Just you see, here you see the voltmeter resistance is what? I have told. The resistance of voltmeter ideally it is infinite. If it is infinite, it will just behave like open circuit. That means no current will flow through this voltmeter. So whatever current will start from the positive terminal I, it will come to this load. Okay, so that means current will follow this loop, this path. It will not go through the voltmeter because voltmeter resistance is infinite. It will behave as open circuit. So now what is the current? So if we apply the Kirchhoff's voltage law or Ohm's law, you can say. So here what is the voltage in this loop? Here voltage in the loop is E. And what is the total circuit resistance in this loop? So here the internal resistance, here the external resistance. So here ammeter is connected whose resistance is say RA. But we know the ammeter resistance is 0. So that implied E is 12 by R is 2 plus this external load is 4. So that is equal to 2 ampere. Now this ammeter will read what value? 2 ampere. So this is the ammeter reading. Ammeter will show 2 ampere. Now we have to find the voltmeter reading. So what is the voltmeter across these two terminal? The voltage across these two terminal is nothing but voltage of this source. So what is the voltage of this battery? It is maximum is E, and from there is a internal drop. So this is your V. So V is equal to E 12 minus I is equal to, you got 2 into R R internal resistance is 2, so that is 8 volt. Or you can say, you see, if this terminal is A, this terminal is also A, because in between this point to this point there is no resistor or any other electrical element. So potential at this point is same as potential at this point. If this point is A, this point is also A. If this point is B, this point is also B, because ammeter will behave short circuit. Resistance of ammeter is 0. So potential at this point is same as potential at this point. So now the voltmeter reading across A and B is same as voltmeter reading across this A and B, which is connected to the external resistance. So here what is the value of the current? Current is flowing through this R is equal to I. So what is the voltage drop across AB? So I can write V, you know, V is equal to IR. So voltage across AB is equal to current through AB and resistance across AB. So that is equal to, what is the current through this branch? That is 2 ampere. What is the resistance of this branch? 4 ohm. So you will get same result, that is 8 volt. Same result. Okay. Next we will find what is the energy conversion rate by source. So here it is under example 25.1. What is the energy conversion rate by the source? So this source will provide energy, or the rate of energy of the source is nothing but the maximum power delivered by the battery. So the rate, or you can say power, that is maximum power delivered by source is equal to E into I. E into I. So E is equal to 12. I is equal to what? 2 ampere. So that is 24 watt is the maximum power delivered by this battery. And from that power, there is some internal loss inside the battery due to internal resistance. So that is called energy rate. Energy rate of dissipation. That is what energy is lost in this internal resistance. And its rate of energy dissipation is called power. So that is the power loss, we can say power loss inside battery. Power loss inside battery due to what? Due to internal resistance is nothing but I square R. What is I? It is 2 square. What is R? It is 2. That is equal to 8 watt. Okay. So now what is the battery's output? Net output power of the battery. So net power output of battery is equal to maximum power given by the battery is 24 watt. Out of that there is some loss, that is 8 watt. So that is equal to 16 watt is the available power for this load. Or we can say directly write down the net power, or it is called output power across the load is equal to I square into R. What is I? 2 square. What is R? R is equal to 4 ohm. So that is equal to 16 watt. You can directly calculate like this, or the net power is equal to maximum power EI minus internal loss I square R. So that is equal to 16 watt. So this is example 25.6, beautiful example, concept based example. You see there are two circuits. Same battery, 12 volt internal resistance 2 ohm, 12 volt internal resistance 2 ohm. External load is 4 ohm, external load is 4 ohm. Here voltmeter is connected across the load, that is parallel to the load. Here voltmeter is connected in series. Ammeter here connected in series, here also ammeter is connected in series. So in the both case, first we will find what is the current in the circuit, what is the ammeter reading. You see, you know the resistance of voltmeter is infinite. So whatever current will start from this positive terminal, same current will flow through this ammeter and through this external load resistance, and finally it will reach at the negative terminal of the battery. So no current will pass through this voltmeter because the resistance of the voltmeter is very high, that is infinite. Okay. So now here what is the value of current? Current is equal to, this current will flow in this closed circuit. So what is the EMF, total EMF, that is E, divided by what is the total resistance in this circuit. resistance of the internal resistance plus resistance of the ammeter plus resistance of the external load. So that is equal to E is equal to 12 volt divided by small r is equal to 2 plus ammeter resistance, it is ideally 0, plus resistance of this load is 4, that is equal to 2 ampere. So that means this ammeter will show 2 ampere. Then what is the voltmeter reading? What is the voltmeter reading? So this voltmeter is connected across what? These two terminals. So what is the current through this? I. What is the resistance? R. So I can write V A dash V dash, that is voltage across these two terminals, is nothing but I into R. I is equal to 2, R is equal to 4, that is 8 volt. Or in another way you can find this point is same as this point, this point is same as this point. If the potential difference across this is equal to V, potential difference across these two terminal of the battery is also V. So we can write VAB, which is nothing but V A dash V dash, is equal to what is the voltage across terminal voltage across a battery? E minus IR. E is equal to 12 minus I is equal to what? I is equal to 2 ampere into internal resistance is 2, that is equal to 8 volt. You can calculate in this way also. Now come to this circuit. So here it is a closed circuit. So current, what is the value of current in this circuit? The total EMF is E by internal resistance plus resistance of ammeter plus resistance of this external plus resistance of the voltmeter. You see the voltmeter resistance is infinite. So that means E is equal to 12 volt divided by infinite plus something is also infinite, that means current will be 0. So that means this ammeter will show 0 ampere reading, 0 ampere. Then what is the reading of voltmeter? So this voltmeter is connected between this point, let us say this point is A, this point is B. Now you see, since current in the circuit is 0, so voltage drop in the circuit is 0. So here, what is the voltage drop? IR is equal to 0. Here, what is the voltage drop? I into R, that is also 0 because current is equal to 0. So that means potential at this point is same as potential at this point because there is no voltage drop. So potential here, potential here, potential here, potential here also because there is no voltage drop. So that means whatever potential is there in this terminal, so this is the potential at this point. And this negative terminal is connected across this B point. So now you see what is the potential difference across these two terminals, that is 12 volt because it is battery, and here internal here current is 0, so there is no voltage drop. So if the potential difference across these two terminals is 12 volt, this point is same as this point, this point is same as this point, so the voltage across or potential difference across this point is also 12 volt. Okay, so here this voltmeter will read 12 volt. So then what is the problem here? Generally we say voltmeter is always connected in parallel, but here voltmeter is connected in series. If we connect voltmeter in the series, the total current will be 0. So no current will flow through the load. So that is why we always connect voltmeter in parallel. Now let us solve example 25.7 and example 25.10. So here we are combining the two examples because this is a common circuit. So here you see in this circuit, if A and B are short circuited, you see this is A terminal, this is B terminal. I am short circuiting this A and B terminal. That means I am connecting this A and B by a wire without any resistance. So this is called short circuited between A and B terminal. In this case, you have to find what is the voltmeter reading and what is the ammeter reading. Okay, so this is your example 25.7. You have to find first voltmeter reading and ammeter reading. So before calculating the voltmeter reading, calculate the ammeter reading. You see, so I have already explained. So here current will start in this way. Current will start in this way. It will follow this path because the voltmeter resistance is infinite, so no current will pass through this branch. Then what is the total current in this circuit? So I is equal to total EMF divided by total resistance in this circuit. Total resistance is smaller and resistance across this AB terminal, which is short circuited, plus the resistance of ammeter. So that is equal to E is equal to 12 volt divided by small r is equal to 2 ohm. You see, what is the resistance across this A and B terminal? It is short circuited. Just A and B are connected by an wire whose resistance is 0. So you know, in short circuit condition, resistance across the terminal is 0. Plus resistance of ammeter we have told 0. So that is 6 ampere. So this ammeter will show 6 ampere reading. Then what is the voltmeter reading? So I will not explain frequently. You see, the voltmeter reading V is equal to, it is the voltage across the two terminal of this cell. So V is nothing but E minus IR. E is equal to 12, I is equal to 6, R is equal to 2, that is equal to 0 volt. Now see, this point is same as this point. This point is same as this point. Because potential at this point is same as this point, there is nothing resistance, no resistance is connected. Here from this point to this point, there is no resistance because resistance of ammeter is 0. So this point potential are same. So I can directly find that what is the voltmeter reading. That voltmeter reading will read the voltage across A and B terminal. What is VAB? It is IAB into RAB. What is the current? Current is equal to 6. What is resistance across this AB terminal? That is short circuited. Resistance is 0. So voltage is equal to 0 volt. Okay. So I had got in this way. Also I can directly find the voltmeter reading. Next, find the rate of energy conversion. So who is converting the energy? Battery. Battery is converting which energy to which energy? Chemical energy to electrical energy. So the rate of energy, that means power. The maximum power of battery can provide E into I. What is E? 12. What is I? 6. 72 watt. Now, out of that, some power is dissipated by the internal resistance. So, internal resistance will consume some power. So, power dissipation or the energy rate of dissipation. Energy rate means power. Power dissipation by the internal resistance of the battery is equal to I square R. I is equal to 6 square. R is equal to 2. That is equal to 72 watt. Now see, battery can develop 72 watt and battery can consume also 72 watt. So what is the net power output of the battery? So 72 minus 72, that is 0 watt. So this is the net output power. You can directly calculate also net power. So net power means it is the power across the terminal A and B. So what is the formula of power? I square R. What is I? I is equal to 6 square. And what is R? Resistance across the short circuit terminal is 0. So that is equal to 0. Now, tester understanding 25.4 and 25.5. Two tester understanding I am doing simultaneously. You have to rank the current and net power from highest to lowest value for the three cases. Here you see the first bit, a 1.4 ohm is connected to 1.5 volt battery with internal resistance 0.1 ohm. Suppose this is a battery whose EMF is equal to 1.5 volt, internal resistance is 0.1 ohm. This is connected across a load of what resistance? 1.4 ohm resistance. So question is, you have to find the current and net power output. So in this circuit, that is first circuit, so current is say I1. So what is I1? I1 is equal to E, that is 1.5 volt, divided by total resistance, that is 0.1 plus 1.4, so which is equal to 1 ampere. So in the first case, current will be 1 ampere. Then what is the net output power? So net output power means power across the output load. So here, what is the net output power? I1 square into R. So I1 is 1 into R is equal to 1.4. So that is equal to 1.4 watt. Come to second case. In the second case, it is given 1.8 ohm is connected to 4 volt battery. So this is a battery whose EMF is equal to 4 volt. 1.8 ohm is connected across the battery. That is the external resistance is equal to 1.8 ohm. And it is to 4 volt battery having terminal potential difference of 3.6 volt. If we connect a voltmeter across these two terminals, so that voltmeter will read what value? 3.6 volt. But an unknown internal resistance. We don't know what is this internal resistance. We don't know. So we have to calculate what is the current. So how will you find the current? You see, you know what is the formula of current? I is equal to E by R plus R. So here R is not given. So R is unknown, I is unknown. You cannot solve in this formula. But you know, if the current through this is I and resistance is 1.8, then voltage across this is equal to V is equal to I into R. V is equal to I into R. So here what is the value of, so that implied I is equal to what? V by R. So what is the potential difference across these two terminal or across the battery? It is 3.6. So V is equal to 3.6. Resistance is 1.8. So that is equal to 2 ampere. So here current value is 2 ampere. Then what is the net output power? So net output power. So I can say it is I2, current in the second circuit, I2 2 ampere. Then what is the net output power? So net output power is equal to P2. So this in the first case, the net output power is P1, here P2. P2 is equal to what? I square into R. So what is I? 2 square. What is R? 1.8. That is equal to 4 into 1.8. It is nothing but 7.2 watt. Come to third circuit. In the third circuit, an unknown resistor connected to a 12 volt battery that has an internal resistance of 0.2 ohm. So this is a battery of internal resistance 0.2 ohm and the battery EMF is equal to what? 12 volt. It is connected to an unknown resistor. The external resistance, that is R, is not known. It is unknown. And terminal voltage of 11 volt. So what is the terminal voltage across this load? So V is given 11 volt. Okay, so you have to find the current. So how will you find the current? If you find the current, I is equal to E by R plus R. So here R is not given. So I is unknown, R is unknown. So you cannot go in this way. But you know this terminal voltage. Okay, now you see. If you so what is the voltage across the battery? What is the voltage across the battery? So V is equal to the maximum voltage given by the battery is 12 volt minus there is some internal drop. So that implied V is equal to what? It is given 11 and the total EMF is given 12 minus I is unknown. Internal resistance is 0.2. So from this only one unknown is I. So you can write it is I3 because it is the current in the third circuit. So I am giving I3. So you just calculate. So I think it will come 5 ampere. So I3 is equal to 5 ampere. Then what is the net output power? Net output power is equal to I square into R. I is 5 square into resistance. Of course, we don't know. Yes, we have not calculated resistance. So in that case, you can find net power is equal to V into I. So V is equal to voltage across this, which is given 11 into I. I is nothing but 5. So 55 watt. And what is the question? You have to rank the current from highest value to lowest value. You see, So in the first case current is 1 ampere, in the second case it is 2 ampere, in the third case it is 5 ampere. You have to write from highest to lowest. That means current in the third circuit is greater than current in the second circuit, greater than current in the first circuit. Similarly, you have to rank the power from highest to lowest. In the first case, power is 1.4 watt. Second case, 7.2 watt. Third case, 55 watt. So highest power is in P3. So P3 is greater than P2 is greater than P1. Exercise 25.28. It is a problem from University Physics book on from exercise section. So terminal voltage of 24 volt battery is 21.2 volt. Since it is given terminal voltage of 24 volt battery, that means the EMF is equal to 24 volt, and terminal potential difference, terminal voltage is given 21.2. So you have to find what is the internal resistance, what is the external resistance. So you see, suppose this is your EMF, and this is EMF, that is 24 volt. This is the internal resistance, and across these two terminals there is an external resistance connected. We don't know this R value, we don't know this internal value, but the terminal potential difference is given 21.2 volt. That means the voltage across this is equal to terminal potential difference, which is same as voltage across this battery. So that V is given, E is given, but R and R is not given. So how can you find? We know what is the relation between E and V. E is equal to V minus IR. Okay, E is equal to V minus I into R. That implied I is equal to E minus V. No, here data is also given. The current in this circuit I is also given, that is 4 ampere. Terminal voltage is given, the EMF of the battery is given, and current through the circuit is given. Current through the circuit is given 4 ampere. Current is also given. That means I is also given. Then you have to find the internal resistance. Very simple. So you see, the IR is equal to VIR. So this is no. You see, just so V is equal to E minus I into R. Sorry, V is equal to E minus I into R. So that implied I into R is equal to E minus V. That implied R is equal to E minus V by I. So E is equal to 12 volt. V is voltmeter reading is given 21.2 divided by current is given 4. So now you calculate this, so you will get 0.7 ohm. This is the internal resistance. Then what is the external resistance? So you see, here current is I. So I into R is the voltage across this. So terminal voltage V is equal to I into R. So that implied R is equal to V by I. So V is equal to what? V is equal to terminal voltage 21.2 by 0.7. So if you calculate, it will come 5.3 ohm. 5.3 ohm. So this is the, sorry, R is equal to V by I. I is nothing but what? I is nothing but 4 ampere. So 21.2 by 4 is equal to 5.3 ohm. So I think this is last problem of this today's video. So exercise 25.42. A radio receiver operates at 6 volt, draws a current of 0.1 ampere. Find how much electrical energy will it consume in 2 hours. So this is the actual question given in 25.42. But I have added this question for your easy calculation, for your concept. I had given extra, that is, if it operates for 10 hours daily and unit cost is 3 rupees, what will be the bill for the 1 year? You see, you know what is the unit of electrical energy? Energy is nothing but power into time. So power is expressed in watt, time is expressed in second. Generally, watt into second is not called joule, though it is called joule, but in electrical circuit, we can take energy is in terms of watt second. But watt second is very small unit. So if we will convert into watt into kilowatt, so power is kilowatt, and the second, if we will convert into hour, so this is called unit of energy, kilowatt hour. And 1 unit of electrical energy means what? 1 kilowatt hour. Okay. Suppose in your house you have consumed 200 unit in a month. That 1 unit means what? 1 kilowatt hour. 200 unit means 200 kilowatt hour. Okay. So this is the unit of electrical energy. Here a radio receiver operates at 6 volt. So the voltage rating or the radio is operating at what volt? Terminal voltage is 6 volt. It draws what current? 0.1 ampere. And how much electrical energy will it consume in 2 hours? So the radio operates for 2 hours, let us say. Then what is the electrical energy? So you know electrical energy, let us say U is equal to power into time. Power is nothing but V into I into time. So here voltage is equal to 6 volt. Current is equal to 0.1 ampere into time. Time is equal to 2 hour. Okay. So here you see this is 6 into 0.1, that means 0.6. So 0.6 is what? Volt ampere. Volt ampere is watt into 2 into hour. So that means we are getting 0.6 into 2 is how much? 1.2 watt hour. Watt hour. Or if you will divide 1000, watt can be expressed in kilowatt. Okay. So 1 kilowatt is equal to 1000 watt. So divide 1000, you will get kilowatt into hour. So that is equal to 1.2 into 10 to the power minus 3. And you know 1 kilowatt hour is nothing but unit, 1 unit. So radio consumes this unit of energy in 2 hours. Next question, which I have added here. If that radio operates 10 hours daily with same voltage, same current, what will be the electric bill you have to pay in 1 year? So that means we have to calculate total energy in 1 year. Total energy in 1 year. So what is the energy? Again, V I into T. V is equal to 6 volt. And current is equal to 0.1 ampere. Okay. So this is expressed in what? Watt. And if you divide 1000, you will get what? Kilowatt. And what is the time? For daily, what is the time? In 1 day, the radio operates for 10 hours. And we have to calculate bill for 365 days. So in 1 day, this is the total unit consumed. In 365 year, you have to multiply 365. So you just calculate, you will get just if you calculate, you will get 2.19 unit. Okay. So each unit cost is given 3 rupees. So that means total bill the radio operator has to pay is equal to what? For unit cost is 3 rupees. There are 2.19 unit will be consumed in 1 year. So 2.19 into 3, that is 6 rupees 57 paisa. So this is the total bill. So with this, I completed the chapter 25. So next we will start chapter 26. Till that, take care. Okay, bye.